All right, guys, let's start off on number 8 here. So for this one, it's an exponential equation, so we want to isolate the base. I see the base is e, so I need to divide this by 2 first. The base is not 2e, it's just e. So I'm going to say e to the 12x equals, and I'm just going to leave that as a fraction. You could do a decimal as well, it's fine either way. And now I'm going to switch this into log form. So since this is an exponential of base e, I'm going to do a log of base e, but for log of base e, we just write that as ln. And then the new partner then will be 17 over 2, and then that's going to be equal to 12x. So what was in the exponent is now isolated. Last step here, I'm just going to divide this by 12. So I'm just going to type that in the calculator, just like that, with the 17 over 2 inside of the log and the 12 not. And so when I do that, I get 0.1783. So to 4 decimal places, that's my answer. All right, next up we got number 10 here. So for this one, you can go ahead, I would just divide this 4 over to start here. So then I have 1 plus 10 to the 5x equals, let me write that x better. Here we go. Okay, so that's going to equal 9 over 4. And then I would subtract 1 from this side, but I would subtract 4 over 4 from this side, just for the common denominator. So 10 to the 5x now equals 5 over 4. Now ready to switch it into log form. So we're going to go log base 10. Now when we're log base 10, we actually do not need to write the base. So it's just going to be 5 over 4 in the log, and then that's equal to 5x. So then I just have to divide that by 5 outside the log to finish isolating x here. We're just going to type that in the calculator then, log, and since I don't write the base, it's assumed it's base 10 of 5 over 4 all over 5. And when we type that in, we get x equals 0.0194. All right, next up here, we have another exponential equation, but the problem with this is really both of these, there's kind of an x in both of the exponents. So we have to kind of choose a base to work with here. We can actually do this as a log base 7 or log base 5. I'm going to go ahead and do this as, I'll do it as a log base 7. So if I do that, I'm going to write it as log base 7. And then if 7 is my base, that means this is the new partner. So I'm going to write all of that 5 to the power of 1 minus x. And then that's going to equal x over 2. Right there. Okay. So then next thing is I see that I have a exponent right here inside of a log, so we can always take that and move it to the front and let it be a coefficient instead. And so then I just have here log base 7 of 5. And then I would actually write this side as 1/2 x just to make it a little easier on me. Think about combining like terms there. All right, so then next up, I want to get a decimal for this, so I'm going to do in my calculator log 5 over log 7. So just a second while I calculate that. So if I do that, I get 0.8271. So I'm going to go ahead and replace log base 7 of 5 with that. I'm actually going to change this to 0.5x since I see we're working with decimals here. So next up, I'll go ahead and distribute this into that parentheses. So that'll just make 0.8271 minus 0.8271x equals 0.5x. I would just, I forgot the 7 there. Okay, so then I would get my variables on the same side. So I'm going to add 0.8271x to both sides. So now you can see why I changed that to the 0.5. So now we get 0.8271 equals, let's see, if we add these up, we get 1.3271x. So then I'll just divide by 1.3271 on both sides. And that'll give me my x equals, so we'll just do that, divided by 1.3271, and that'll give me x at about 0.6232. All right, next up we got number 24. I see that my x is in the exponent, so I'm going to have to use logs, but it's in the denominator, so I would first multiply that denominator over to the other side. And so that's going to cancel out, and then I get 10 equals. I'm going to go ahead and just leave this 2 undistributed. You can distribute it as well, but I'm just going to leave it outside and then divide it back over here. So I get 5 equals 1 plus e to the negative x. I'm then going to subtract the 1. So I get 4 equals e to the negative x. And then I'm ready to switch to log form since I have my base isolated. So I'm going to switch it to log base e, but that's just ln. The new partner is 4, and then negative x is isolated. So I'm just going to divide this by negative 1 on both sides. So I isolate my x. I'm just going to type this into my calculator. It's really negative ln 4, which is really the same as ln 4 divided by negative 1. So let me see what that is. So that's going to come out to x equals negative 1.3863. All right, next up here we have a log equation. So for these ones, we first want to kind of switch this into the exponential form. So I see the base here is 2, and then the new partner is 2, and then that's going to equal all of this. All right, I don't want to factor yet because we never want to factor equal to anything other than 0. So I'm just going to evaluate this as 4, and then I'm going to subtract that 4 over to this side. So now we have 0 equals x squared minus x minus 6. So now we can factor. It was x minus 3, x plus 2. And then we will split these up, set them equal to 0 individually. So x would equal 3 and x would equal negative 2. Now we do need to check these for extraneous solutions on logs. And all that means is we need to make sure it doesn't... All right, so I have to plug this back into the original log way back there. So if I do this one as 3 squared minus 3 minus 2. The only thing I have to make sure is this doesn't come out negative inside of a log. So this one would be, let's see, 9 minus 5 would be 4. So that one does check out, so 3 is good. But if I do negative 2 squared minus negative 2 minus 2, that's 4 plus 2 minus 2. That's actually 4 again, so that one is good as well. So these are both good. They're not extraneous. Even though the one was negative, when I actually plug it in, it makes the inside of the log positive. Yeah. All right, next up, number 44. So for this one, what I would do is I would actually combine these two logs that are adding. So that's going to be log of. And since they are adding as separate logs, I would multiply the insides, which of course means distributing, like so. And then on this one, I would actually take that 2 that's out front, and I would make it an exponent inside. So that's going to be x squared. All right, now a rule on this when we have log equals log, you're actually allowed to just drop the logs. You cannot do that if it's log equals number. But in this case, when it's log equals log, you can just drop them. So what I can do then is just call this x squared equals 6x minus 8. So since the logs were the same, I can just get rid of them. But you got to combine them into 1 each. So now this is a quadratic, so I need to get one side to 0 to solve it. And then I'm going to factor. Looks like it's x minus 4 and x minus 2. That's equal to 0. And so I would say x equals 4 and x equals 2. And when I plug these back in, and I'm going to plug these into the original logs way back here, wherever there's an x. Obviously, I don't need to plug it into that one where it's a 2. I see that when I plug in 4, this one's good as it's just 4. This one is, let's see, 12 minus 4, so that's definitely positive, so 4 checks out. For 2, I plug it in. Obviously, the first one is positive. The second one, 3 times 2 minus 4 is positive as well, so this is good as well. They are both correct. All right, next up, number 46. So for this one, once again, we're going to combine these two logs over here. So it's going to be log base 5 of, and then we're going to multiply those. So x squared plus x. And then that is equal to, oh, and that's in the log, so I'm going to put parentheses there. That's equal to 20. Actually, it's not equal to 20. It's equal to log base 5 of 20. So this is significant because, once again, when we have log equals log, we can just drop the logs and say x squared plus x equals 20. And since that's a quadratic, once again, I'm going to get one side to 0, so I'm going to subtract the 20 over. And then I will factor, so x plus 5 and x minus 4 equals 0. So x could equal -5, and x could also equal 4. I need to plug these back into the original log. So for -5, I see that it makes both of those negative. If it made either one negative, I already know it's extraneous. So this one is definitely extraneous. But I see that when I plug in 4, it makes both of those positive inside, which is good to go. All right, next up, number 48. Once again, I do want to combine these two logs here. So I'm going to multiply their insides to combine them. And in this case, it's equal to 1. It's not equal to log of 1. So in this case, we're not allowed to just drop the logs. We have to do our exponential switch. So I'm just going to remind myself that this is really a log base 10. And I'll rewrite it as an exponential. And the base of my exponent will be 10. The new partner will be 1. And that'll be equal to x squared minus 3x. Now this did still turn into a quadratic. So I need to get one side to 0 and factor. So I'm going to subtract the 10 over. I got a special guest here. My son is helping me out by holding my stylus. All right, and so I'm going to go ahead and factor now. So it'll be x minus 5 and x plus 2. So x could equal 5, and it could also equal -2. However, when I check these for extraneous solutions, I notice that 5 is good to go. It makes both of those positive. But -2 makes both of these negative, so that's going to be an extraneous solution. So we got two answers, but one of them is extraneous, so we really only have one answer here.